Okay, so last night you had to do pages 23 through 27. I'm gonna kind of do this the way we were doing, the way we were going over the Regents questions, where I give you the answers and you let me know if you need me to explain them. So starting off with number 1, high tides happen approximately every 12 and a half hours. Number 2, when will the next low tide? You don't believe me, the 12 and a half hours?
I got it right. Oh, no.
So it only asks about the high tide. So there's a high tide a little after 6 a.m. There's the next high tide, which is a little more after 6 p.m.
You got it now.
So to me, that looked like 12 even, but as you can see, they keep getting a little bit farther after the 6. So it is 12 and a half hours. So when will the next low tide be? Well, here was the last one. And again, they happen just like the high tides every 12 hours. So the next low tide will be around 3 a.m. Now we're talking about, it says, what happens if the distance between the Earth and the Moon were to decrease? Hey, by the way, what does it mean if the distance between Earth and Moon decreases? What does that actually mean? They get closer. And what do we know happens with gravity when things are closer? What happens with gravity when gravity is stronger? So if there's stronger gravity, what's going to happen with the tides?
It's gonna be higher.
And
the lower ones are gonna get lower.
There you go. High tides will be higher and low tides will be lower. That's answer 1. Do you need me to go slower?
No,
okay.
Sarcasm.
All right, moving on. What happened? How much time is required to go from position 3 to position 7? So notice that's halfway around. That takes about 2 weeks because it does take 29 days to go all the way around, which is almost a month.
Man, that really reeks.
Okay. As the moon changes location from position 2 to position 6, you don't have to do this, but what I did is I labeled each one with their phase. So I did that by doing the whole scenario where I moved that moon on top. I see that this is light on the right, so it's waxing. It's mostly dark, so that's a crescent. I kept going around. This is a waxing quarter, waxing gibbous, full moon, waning gibbous. So then what happens to the lighted up side that you could see? Well, it goes from it increases till the full moon, but then it starts to decrease after that. So it increases, then decreases. Answer 4. What causes gotta look at that carefully.
I did that wrong.
That question was not straight.
Yeah, well, that's because you didn't look exactly that we went from 2 to 6, not just 2 to 5. So why do we see different phases? That's because the moon is revolving around Earth. And then if we put a full pulse pendulum on the moon, it would provide evidence that the moon was rotating. And then the next question asks in position 2, so this position, which one of those pictures would be correct? It comes in handy that I already labeled number 2 as a waxing crescent. So then I just need to look at this picture and which one is a waxing crescent? 2 is a waxing crescent. Now we got to decide, is this, first of all, a lunar eclipse or a solar eclipse? Just like we said yesterday, you've got to decide what's getting blocked. So the sun is getting blocked. If you were standing on the Earth, the sun is getting blocked. So it's a solar eclipse. And who's going to see the solar eclipse, A or B? A. Now we want to know where the high tides are going to be. And what do we know about high tides? High tides
Gravity from the moon.
are from gravity from the moon. I don't have an extra pen. I got pencils right here though. So remember, high tides follow the moon. So wherever the moon is, that's going to be where the high tides are. So there should have been a dot here and a dot there. to show that the high tides follow the moon. On the next page, so tides and moon phases. This is good review of chapter 1. Are they cyclic or non-cyclic?
Six.
Yeah, they happen in a
That's weird.
cycle.
Don't say it
Why?
like that.
Cyclic.
Cyclic, yeah.
And because they're cyclic, are they predictable or unpredictable? Yep,
So
that is,
cyclic, you take like, oh.
no, it,
Doesn't matter.
just, the word is cyclic.
You say potato.
Ocean tides, are they best described as which one? Guys, ocean tides. Two. Predictable and cyclic.
Hydrate quickly.
Oh, that doesn't have anything to do with anything, but
Earthquake.
spring tides, remember from the notes yesterday, spring tides, they're called springs because they stretch way out and then they squish way in. So they're the highest high tides and the lowest low tides. They happen when the sun gets in on the moon's gravity action. So that's going to be anytime the sun, the moon, and the earth are in a nice line like that. So that's answer 1 and 5. This question again asks basically the same question. The highest high tides occur when the sun gets in on the action. So in this case, it's 1 and 3. Does anybody need me to go
I
over
got those, like, oh,
in any more detail? Did you check your notes when you were doing them? So blindly answering these questions is really, well, you couldn't have because there's nothing in your reference table about this.
Like the.
Yep, so definitely, guys, check your notes when you're going through these questions, because that's how you learn things. You check your notes. So the highest high tides follow the moon and the sun. Okay, so we have to finish this chapter up. So what I'd like you to do is, I believe we did, if you turn your page, we did the entire our solar system page. Is that correct?
What page is that?
The next page.
Yeah.
Yep, so that's the next page.
Correct.
Do you find it? So go to your homework and turn the page one more. There you go. So our solar system should be 100% complete. If you don't have it, you need to go back into the videos and watch it. This is where I'm not sure. Do you have all of the galaxy part?
Yes.
Do we have the definition of the universe?
Yes.
Do we have the Big Bang Theory?
Yes.
But we don't have evidence, right?
We have some.
It's some. Okay, that's where we need to pick up. So,
Well, how much are we supposed to have? It says the universe is still expanding.
okay, that's
Right.
almost it. Yeah, okay, then we got it all. So that's where I'm gonna start though. So we're on the page that starts with galaxy. And we are just about done, but I am gonna kind of start there again, just so it kind of makes a little more sense what I'm talking about. So we have our galaxy, and we talked about the galaxy. So a galaxy is not all the stars in the sky, but it is billions and billions of stars, planets, moon, and all the space matter that goes with them. We live in the Milky Way galaxy, which is a spiral galaxy, just like that picture you have there that looks like this. Where are we? We're right about there. So we're just basically not important enough. And we are on one of the spiral arms. The universe, however, is everything that exists. Every galaxy, every star, every planet, every moon, everything. Everything is part of the universe. How did the universe start? And we already did this with the Big Bang. So Big Bang, just like it sounds like, is a big explosion. And when things explode, and I think we talked about this the day we did these notes, they go, right? And they go
They
out.
all come back together.
Eventually, but we're not there yet, because part of the reason, so honestly, the Big Bang Theory and this explanation of how it happened, if you wanted to get your doctorate degree, so not 4 years of college, not 2 years of college, but probably 6 to 8 years of college. And you wanna start, this is what you'd be studying, the Big Bang Theory, or one thing you could be studying. That this is what the guys on the show, The Big Bang Theory, were trying to prove. They were kind of trying to explain, well, how do we have this Big Bang? Stephen Hawking, this is the stuff he was working on. So, not me. So, I don't have any answers for you.
Oh, so that's good.
Yeah, not great. Not that, no, not that educated.
Oh.
So, what I'm saying is, you don't have to understand all the science behind the Big Bang, because not only do you not understand it, I don't understand it.
NASA.
Most of my professors in college probably didn't understand it. Stephen Hawking somewhat understood it, but was looking for ways to explain it. But what they do know is there is some evidence, because some people are like, well, how do they even know it happened? And again, we don't know exactly how it happened, but we know some sort of explosion happened because the universe is still expanding. What they can figure out is this thing called the redshift. Again, the redshift is somewhat over our head. Not somewhat, it's way over our head. Like, it's really complicated. So let me give you a very basic explanation of the redshift. So this thing right here, called spectroscope, I think is how you say it. So when you look through this, and I'll pass it around if you really want to see it, and when you shine it at the light, you'll see a rainbow. And the rainbow, when I shine it at the light right here that's not moving, is kind of just a normal rainbow, like you would expect. But if I was to shine this, let's say somebody was in a car driving away, and I shined this at the car driving away, the rainbow would be squished to the red side. So instead of having a nice, neat, organized rainbow, it would be squished over to the red side. If I was to shine this and look through it at a car that was driving towards me, the rainbow would be shifted to the blue side. It's a little complicated, so let's turn the page and write this down.
Can we look at it?
I'll pass it around, yeah. So you're writing this, basically you've got these exact same pictures in your notes. So I'll pass this around while you write this down. Again, there's nothing really exciting in it. You look in it and see a rainbow.
I wanna see a rainbow.
I wanna see a rainbow.
Okay. So write this down while you wait for it to come around. So the first thing, these spectral lines. That's what you're gonna see when you look through that guy right now. So it's gonna be the light getting separated into the rainbow. And they're just kind of in the middle area.
What's the numbers in it?
It's the wavelength of the colors. So remember when we did the electromagnetic spectrum?
Yeah.
Those are actual numbers for the wavelength.
Joe?
Now, the redshift, like I was saying, if you look at objects that are moving away from you, the rainbow is squished over to the red side. Other side, Jeff.
What is that?
No, the blue shift.
Like that?
No, kind of like the way I did it, but you're wasting time now, Jeff.
I don't know.
Okay,
Oh,
yeah,
that's right.
yeah, just like I did.
Gotta stop wasting time. Oh, okay.
No, I think Keith wants to speak too.
Oh, you.
So guys, the science behind this is baffling. For me, for you, for real scientists working on this stuff. It's the stuff that makes your head explode.
I want to know that.
So, and that's great. People need to want to know about it. I can't teach it to you.
Oh.
This is what you need to go to college for astronomy, for physics, things like that. That's what you need to do here. But what do we need to know? We need to know the redshift tells you that the galaxies are moving away. So what scientists do is they take a much fancier version of that thing, like on a telescope, a really high-tech one. Guys, is anyone listening to me?
Yes, I am.
Okay, we have final in 17 days. So what they do is they point that at stars millions and billions of light years away. And they can see that that rainbow that they expected to be in the middle if it was holding still is all squished over to the red side. So it proves that that star is actually still part of the explosion that's going out and out and out. How I remember this. If you were to look at a car, did you see it, Cassidy? If you were to look at a car that was driving away, what lights would you see? The back ones, the tail lights. What color are those?
Oh, yeah.
Red. So cars that are driving away from you, you see their tail lights, red tail lights. If a car is driving towards you, especially if they have those fancy blue headlights,
Oh, I don't like those.
I don't like them either, but if they're driving towards you, you see the headlights and not the point.
And then
Look with
they
me here.
blind you.
Okay? The key is that the red shift tail lights tell you the car is moving away. The red shift tells you the galaxy or the star is moving away. So this is an overly complicated concept, but what you need to know, red tail lights, red shift moving away from you. Easy enough?
Yes.
Okay. Totally? Okay. Next page. How a star is born.
Oh,
Don't worry, we're not doing all of this. So how a star is born, I am not talking about Tom Cruise and all of those kinds of stars. Huh? Yes, you know he's like an old man.
yeah, I don't care.
Okay.
Tom Cruise.
Like, I feel like he's
At the
like
gym.
too old for me to say this.
Tom Cruise works at the gym. It's just a number.
Okay, moving on.
I know.
Anyway, I'm talking about the stars in the sky. So all of those stars, they didn't just poof, one day show up. They had to go through a life cycle. They had to go through a process of being born, just like anything else, really. And again, this concept is way above our head. And I have never seen them ask a question about this without giving you a huge reading or a diagram. So I am actually going to give you this diagram and we're just going to walk through it. Let's start at the top. Where they really start is a nebula. A nebula has all the ingredients to make a star. It's a cloud of dust, hydrogen, and plasma. So write that in that first bubble. No, right, yep. So, yep.
In the
So
picture.
you notice you have this exact same picture.
Sorry, Miss Brenda.
Okay. I am rushing, I apologize for that. So a nebula has all the ingredients to make a star. Once those ingredients are put together, they make a protostar, which I relate to. Have you guys heard of a prototype?
Yeah.
What have you heard of a prototype for? Yeah, so people designing things or projects. One thing I know they make prototypes for is cars. And then they show them at these like fancy car shows and stuff. So a prototype for, let's say, a car is all of like all the cool features, all the like the beginning of a new, let's say, Ford Taurus. They might have all the bells and whistles. There's some really cool concepts on that car. Do the prototypes usually, are they what's then going to be driving around in a couple of years? No, what do they do to those prototypes?
Adjust.
They adjust it. They make it better for people so that it can either be more affordable or more people want it or more practical. So that's what happens here. So we have all the ingredients. Then we make a protostar, which is like a prototype. But then they get to the like, okay, now what? And they can be two different things. Sorry, this is in the way. So after that prototype, they can kind of take some different paths. Just like a car could become like a regular everyday driver or a fancy luxury car.
Kind of like I drive.
Exactly, just like you drive. Do you have a scooter? Now you broke your ankle? Okay, so one thing that could happen is it could become a massive star, which will turn into a red giant, which could then explode into a supernova and into a black hole or a neutron star. What? So guys, again, I'm not worried about you memorizing any of this. I just want you to know what can happen. The other thing that can happen is it can become what's called a main sequence star, which when that star starts to die, it will turn into a red giant, possibly a planetary nebula, and a white dwarf. Again, I'm not expecting you to memorize any of this. I am expecting you to know it happened and to know there's different paths they can take in their life cycle. Okay? Now, see where it says all those like lines for notes at the bottom? We're not going to put all those because it's actually a lot of notes. It's this, and we're not doing that. We're not doing that, but we are going to put something there. So what you do need to know about a star. So down here it says star formation, get rid of star formation. And just write stars. Shoot, I guess I should have figured out. Stars produce energy through nuclear fusion. So where does the star or the sun get its energy from? The energy that we can feel its heat and see its light. It's through what's called nuclear fusion. So nuclear fusion is a word you need to know. It's how the sun gets its energy. Yes, I did. I was in a hurry. No, it's me. Totally me. Nuclear fusion is a type of nuclear energy. The one we use here on Earth is called nuclear fission. The sun does nuclear fusion. Do you guys know what fusion means? If you were to fuse something. Right, you take one or two things and you put them together, you combine them. So nuclear fusion. So what is fusion? It is two hydrogen atoms combined to make helium. And energy. When you combine two elements, you release a lot of energy. In fact, there's so much that we cannot do this here on Earth. So the sun does it, and any star does it. And the regents will ask you, well, how does the sun produce its energy? And it will more than likely be a multiple choice question. And I, again, have a really stupid way to remember this, but it's fun to say, especially when you're stressed out and annoyed and wish you had another week of school, plus you wish it was also done with school. So that's where I'm at right now. I feel like we need one more week, but I'd also rather be done right now.
No, like I want to be done like before you.
Yeah, I know, and we are almost done, but this is what I say to that. So to remember how the sun makes its energy, I scream, F you, sun!
Whoa! What?
Why do I scream F you, son?
Because fusion and FU.
And it's freaking fun to say. Okay?
F you, son.
Okay?
That's not what I thought you meant.
So FU is for fusion.
F is for
F
fun.
is.
That's your D. That's your D. Color is my son.
Okay? And no, it's not S-O-N. It's not S-O-N like you're the boy child of your parents. No, not that kind of sun. Okay, it is the sun like the sun is in the sky. FU does not stand for bad word you. It stands for fusion. F-U-S-I-O-N. And the reason I say that because the other type of nuclear energy is fission. So F-I. So I want you guys to remember F-U, sun. Can you do that? Will you never forget that one?
Son.
Thank you.
Miss Rose, I'm gonna literally be taking this regents and I'm gonna think of
Okay.
you just yelling.
Okay, so Sarah says she's gonna be taking this Regents and she's literally going to think of me screaming that. Not gonna lie, last year in June, that was a question, and when somebody left, they stopped and said, That is exactly what I thought when I read that question.
Did they scream it during the test?
They did not luckily scream it out loud, but she said she screamed it in her head. So I feel like that was worthwhile, and I will for never not scream
I'll
F you
remember that
son.
when that's the last question, that'll be the ticket to me going out to dinner and then I'm hungry.
You got it. I can't wait. And then we will. No, can't we go somewhere better?
You.
All right, we're guys, we are this close to being done with earth science. So there's lots of stars out in the sky, right? Like, you look up at the sky and you see lots of stars. For the record, you know our sun is just a star, right?
Yes,
Okay,
I didn't know that.
okay, now you do. So that I always take for granted, but I wanna make sure this is just a star. And so there's lots of stars in the sky. Why does our star, the sun, look so much bigger? Okay, cute, we know that. Some of those stars that are out there that look like teeny tiny little sparkles in the sky are huge compared to the sun. They can be 10,000, 100,000 times bigger than our sun, but they look like tiny specks because they are so far away.
What about 2016?
I don't know what the heck you're talking about, Jeff.
That's kind of weird to think about.
It's the things you can literally stay up and like dwell about at night. If you can't sleep and you start thinking like, I don't even want to talk
My
about it.
family was talking about that when we were on our way to Pennsylvania.
So all those stars, so we're on the back of the page we were just writing on. Stars differ from each other. So some stars are different masses, weight, size, temperature, and brightness. So all those little specks, even though they kind of look the same from here, some of them are huge, some of them are tiny, some of them are way brighter than others. Some of them are way hotter than others. Our sun, believe it or not, is just average. It's not that big, it's not that hot, but it's also not super tiny or super cold.
I'm really not lazy.
Well, that's because the angle of insolation is higher. Remember, again, that's not what I'm talking about here, but. So what we call an average star means it's on the main sequence, which we're gonna talk about in 5 seconds if everybody's done writing. So to organize stars, which means to classify them, this guy called Hertzsprung and his friend Russell, they actually developed a graph. And what they graphed is they classified the stars based on their temperature and their brightness. Except for we don't call brightness, we call it luminosity. You guys ever heard of lumens?
Luminous.
They're luminous.
Illumination.
Lumination means to lighten it up, or to provide light. Or
I do that
a
all the time.
lumen is how you measure how bright a flashlight is. I also remember the candlestick in Beauty and the Beast. Anybody remember his name? Lumiere.
I don't even watch Beauty.
Okay, well, that's your loss. But my point is, he's a candlestick and he's called Lumiere, which is talk about the brightness and blah, 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 blah. Okay, if you take French and you know how to say the word.
No, that's just how it is.
Okay, say it again.
Lumiere.
Lumiere, him too. Them too. I don't know what it
Lumiere.
is. Anyway, let's keep going.
I'm Lumiere. I'm luminosity.
Okay, grab your reference table because there is one reference table left and I literally saved it for the last day of teaching.
It's the stars.
Yep, characteristics of
Page
stars,
5.
page, what?
1-5.
Oh, I thought you said 55. I'm like, what are you, nuts? We are on page 15 of your reference table, the top of page 15. The very last reference table we have to look at.
Almost done.
We are, but we only have like 7 minutes, so you guys need to stay with me. So this is a graph of the stars.
Bless you.
So one thing I want to point out is,
Oh,
guys, this is not a map. So sometimes people think this is like a map of the sky. This is not the sky. This is just a graph where every dot represents a star. You can see that they named some of the stars, so they gave actual names to some of them. Doesn't mean the other ones don't have names, but if they named all of them on here, there'd be too many words.
This is a homework question.
Yep.
I got it right.
Okay, on the x-axis is temperature. Kelvin, not Celsius, not Fahrenheit, but Kelvin. One weird thing. Here's 30,000 Kelvin. Here's 2,000 Kelvin. What's weird about that?
Big gap.
Okay.
It goes in deep.
Yeah, so this is the hottest, and maybe you want to label this, and this is the coldest. So it's backwards from how we would normally make a graph. Now notice along with color, or along with temperature, they're also talking about color. Think about a fire. Do fires come in different temperatures or different colors?
You can make them.
And you can make them. One reason fires are different colors are because of the materials they're using either burn hotter or colder. A wood fire, what color are those flames?
Orange.
They're typically in the red and orange side. So notice they're over on the cold side of a fire. Versus like a natural gas or a propane fire.
Blue.
They're on the blue to white side, so those burn hotter. So it's perfectly in order. Blue is the hottest flame, star, and red is the coldest
Look at
star.
green.
No green.
So there's stars that are blue.
Yep.
Don't burn pennies.
Okay. Y-axis. There's two separate y-axes, but they're very easy. Over here on the right, going up, it goes from a small star and it grows to the biggest stars on the top. Luminosity, let's label that. What does luminosity mean again? Brightness.
Good job.
So brightness is over here, and this is in brightnesses compared to the sun. So notice here's the sun right here. So the sun has a brightness of 1. So it's just the sun is the sun. But if we go up to 10, that means it's 10 times brighter than the sun. 100 times brighter. Up to 1,000,000 times brighter than the sun up here at the top. Now going down, it means it's 1/10 as bright, 100th as bright, 1,000th and 10,000th times less bright than the sun, I guess you would say. So let's see if you can answer any questions about this.
Mhm.
Wait, actually, before we do that, do you notice some groups of stars here?
Yeah.
So see
White
how
dwarfs.
right here, this whole section kind of looks like a road going down the middle of the graph?
Yeah.
This is what's called the main sequence. I like to think of this as Main Street. This is where everybody, all these stars behave the way, this is where stars behave the way you expect them to behave. If it was small, you'd expect that star to be cold. So a cold, small star. A hot star is also very bright. Everything on here behaves that way, but then you'll notice another group. Here's a group of white dwarfs. This means they're really small. I think you guys know that dwarfs are small. You can also see that they're down here near the small side.
Pretty scary.
So if we had a dwarf, you wouldn't expect it to be anything spectacular. It's a small, tiny star, but it's one of the hottest stars there are. It's over here on the white side. Giants, if you had a giant, so first of all, you know those are big. Super giants, they're even bigger. You would expect them to be strong and bright and hot. Well, these giants, they're really cold. They're over here on the cold side. So they give them their own groups. So where is our sun?
The one in
It's-
the middle.
So it's right here. It's a main sequence star. Is there anybody on this that has a very similar temperature and luminosity to our sun?
Alpha Centauri.
So if you look, I think it's pronounced Alpha Centauri. I could be wrong. It's almost a twin to our sun. It's a teeny tiny bit brighter, but it's the exact same temperature. Ooh, Polaris. That's one we've talked about a lot.
Yeah.
Altitude of Polaris.
Yeah, altitude of Polaris equals your latitude, but now let's talk about Polaris. What's different about Polaris than our sun?
It's just
Yeah,
a lot
brighter.
brighter.
It is brighter. What about its temperature?
Same.
It's got the same temperature. What color would the star Betelgeuse be? Beetlejuice, Beetlejuice, Beetlejuice.
Orange, red.
So here's Beetlejuice.
Probably like orange.
It's over in the red-orange side. Mic
Whoa.
drop, we're done.
Whoa, okay.
You are done with earth science, but we still have to take a test. We're gonna take the test on Friday. You're not here tomorrow. So we're not doing any reviewing.
And I want me a bit.
Listen.
I heard that.
You be quiet and listen. I don't have time to review with you before this test. I don't wanna take one of the 8 days left as a review day from giving you a review sheet. It's homework. I want you to do it for homework tonight. Here's the optional part. Tomorrow by 9 o'clock, tomorrow by 9 a.m., I will post a video of me going over this review sheet. Do you have to watch it? No, but I will be giving you all of the answers to this review sheet. Why do you want to get all these answers correct? Because I'm going to let you bring this review sheet to the test on Friday. So this is not only a review sheet, this will be a cheat sheet. My concern is if you do it all on your own, you might write down the wrong information. So that is why I will give you the video to watch to get all of the right answers. If I were you though, if you were my daughters and sons, I would tell you, do this first on your own. Then check your answers on the video. You will also be turning this in with your test. Sure, Sarah asked if you can write side notes. Sure, why the heck not? If it's not done, then I guess you don't have a cheat sheet to use for the test.
Good job.
I'm having you turn it in because I don't want, Sarah to do all the work and then she gives it to somebody in period 10, 11, and then they don't have to do the work. They either get the wrong answers, but Sarah's gonna watch the video, so they won't have the wrong answers. But I want everybody to do the work themselves.
Sarah will be taking stuff on Friday.
Oh. Cause you're getting your nails done.
We'll be up at 9 a.m.
Well, I didn't, so, yeah, the video will be there by 9 a.m., but will forever be there.